Okay, so our first example is we have the square root of 28x, the value of x to the third, times the value of y, times the value of z to the 8th power. So if you notice here, you have a blank space right here where your index should be. And remember, we said if we don't see an index, we need to use a 2, not a 1. You're going to use a 2. So now what I need to do to simplify this radical is I need to find all of the prime factors of 28. So you can use either a factor tree or you can use the birthday cake method. I prefer the birthday cake method because I know once I get a 1 on the top as my candle, I am done factoring, and I need to make sure that I'm only picking prime numbers. So it may be handy to have that prime factor list from the previous lesson out until you kind of get the hang of this. So I know that 2 is a prime number, and 28 is divisible by 2 because it's even. So 28 divided by 2 is 14. 14 is also an even number, and it is divisible by 2. So 14 divided by 2 is 7, and 7 is also a prime number, so I'm going to divide by 7, and I'm going to get a 1. So once I see that 1 on top, I know that I am done, and I have found all of my prime factors. So I'm going to highlight those just so that I am drawn to those numbers and not the numbers that created the layers on my cake. So I can say that 28 can be written as the product of 2 times 2 times 7. And now I'm going to expand all of my variables. I know that x to the third is the same as me multiplying the base of x 3 times. And now I have a base of y. It has an exponent of 1, so I'm just multiplying the base of y 1 time. And then I have z to the 8th power. So this tells me that I'm multiplying the base of z 8 times. So I'm going to write z times z times z times z times z times z. I gotta make sure I get enough z's. I should have 8 bases of z's being multiplied. Okay, now we're gonna start making our groups, and this is where your index comes in. You want to circle groups of your prime factors or your variables, but when I make a group, it has to have this many in the group. The index tells you how many to put in your group. So I have an index of 2. That means I need to start circling groups of 2. So I'm going to start with my prime factors. I have 2 2's, therefore I can make one group of 2. That's 1. There's one group. That 2 represents one group of 2. All right. Now I'm going to look at my x's. I have 3 x's being multiplied. I can make a group of 2 right here. There's going to be one group of x's. I only have one y, so I cannot make a group of 2 out of 1, so I can't circle anything for my y's. And now I'm going to look at my z's. How many groups of 2 can I make out of all my z's? Well, I can make 1. There's 2 groups. There's 3 groups. And 4 groups. I can actually make 4 groups of 2 from all of my z variables. Okay. So now after we make our groups, now it's really easy. Now we are actually going to take these groups and we're going to move these groups to the front before the square root symbol. And it's going to look like this. So I'm going to take this group of 2 and I'm going to move it out, and I'm only going to write 1, 2. This 2 really tells me, because I look at my index, that I moved out a group of 2 from my square root. I'm going to do the same thing with my x's. I'm going to move those x's out, and I made one group of x's, so I'm going to put 1x to represent that group. It's not representing how many were in that group, it's just representing the group. I don't have any groups of y to move out, so I'm not going to have a y there, but now I'm going to start moving out my groups of z. So this z represents one group. This z represents the second group of 2 I made. This z represents the third group. And this z that I'm going to write represents the fourth group of z's that I made. So I was able to move out one group of 2's, one group of x's, and 4 groups of z's out of the square root, the radical symbol. And now I'm going to put my square root, because these are moved out, they're no longer in the radicand. So I'm going to put my square root, and now I'm going to write everything that was left. Well, I had a prime factor of 7 left. I had 1x left. underneath the radical symbol. And I also had one y left under the square root symbol, under the radical. And so to clean up my final answer, all I have to do is all of this is being multiplied. So I just kind of have to multiply all this back together. So my final answer is really going to be 2 times x. And then I can rewrite z times z times z times z as z to the 4th. And that's being multiplied by the square root of 7 times x times y. So 7xy. And I have now simplified my radical. What that means, is there any prime factors or variables that we can move out in groups out of the square root symbol so that now we have less stuff underneath the square root. I went from 28 under the square root to a 7 because I was able to move some prime factors out. I was able to go from x to the 3rd power to x because I moved out some x's. I was able to go, the y stayed because I wasn't able to move that out, but I was able to go from z to the power of 8 to no z's under the square root because I was able to move some z's out by taking the square root. And that's all it means to simplify a radical. So let's look at our next example. We are going to look at the cubed root of 32 times the value of a squared times the value of b to the 6th power. So again, we're going to start with 32, and we are going to do the birthday cake method. Well, I always start with 2 if I see it's an even number. So it's going to be 16. I have another even number, so I'm going to divide by 2 again. That's going to be 8. And I still an even number, so I can divide by 2, which is going to give me 4. And I know 4 is divisible by 2, and 2 is divisible by itself. So now I am at a 1, which tells me I am done finding my prime factors. And if I need to double check, I can check that all of these numbers show up in that prime factor list you were given in the previous lesson, so you can check your work. And now I have found all my prime factors of 32.